Hey guys, welcome back to Trig 1-2, second section of the chapter. Let's jump right in. I have up here our two special triangles that we learned about yesterday, and or whenever you did this before, and we decided that this 90-60 side was B, this side was 2b, and this side was root 3b, if you remember from section 1-1. And on the 45-45, these sides are a, and this is a root 2. Hopefully you've done some of the homework from 1-1 and you've worked with these triangles and feel comfortable with them. If not, I would strongly recommend pausing the video and going and doing some of those problems first. So what I want to do is a little algebra problem. Let's say that we have a triangle, and we'll start with a 30-60. So it's a 30-60, and let's say that our hypotenuse is 1, okay? And I want to know what the other sides are. What these ratios do is they allow me to set up a little equation. Well, my hypotenuse is 1, and the triangle tells me that the hypotenuse has a 2b ratio. And in this, by making this equation, I can figure out what b is. I'm going to divide by 2. That means that b is going to be 1/2. So I can then go, well, that means that this must be 1/2. Okay? And if this side is root 3 times b, then that means it's root 3 times 1/2, which is root 3/2. So that's the length of that side. And you can see that it makes sense. If this is our b, 1/2, then this side is twice as big. Well, twice as big as 1/2 is 1. And then this side is root 3 times the short side, which is root 3/2. So hopefully that makes sense. And what we're going to do today is we're going to construct something called the unit circle. So I have that kind of drawn out here at the bottom. The unit circle is a circle with radius 1. And it's centered on the xy coordinate system. So it has an equation of x squared plus y squared equals 1. It's not super important, but just fun, free of charge, little piece of information. So this point right here on the circle is 1, 0, because the radius is 1, and this is 0, 1, because we're on an xy coordinate plane, so it's over 1 up 0 and over 0 up 1. Similarly, this point right here is negative 1, 0, and this point right here is 0, negative 1. Okay? And what we do is we take these triangles and we're going to embed them into the circle. So first I'm going to take this 30-60 triangle and draw that there. This is a right angle. This is my 30-degree angle, and this is my 60-degree angle. And you look at this and you realize that the hypotenuse of this triangle is the radius of the circle. And we know what the radius of the circle is. The radius is 1. So in that way we can say if this is 1, then what are the other sides? Well, we just did that algebra problem up here. This guy had a radius of a hypotenuse of 1, which is what our triangle has. It's just laid over on its side. And so that means that the 60-90 degree side is 1/2. So this guy's 1/2. And the 30-90 side is root 3/2. So the question is, forget about the circle. Let's look at this point in terms of the xy coordinate system and say, what is this point? Well, the way you measure points in the xy coordinate system is you start at 0 and you say, how much do I go over and how much do I go up? So from 0, 0, I'm going to go over, root 3/2. That's this distance right here. And I'm going to go up 1/2. That's this distance right here. That's how I get to this point. So I can construct a coordinate in the XY coordinate plane that is also on this unit circle. All right, now I can take this 30, 60, 90 triangle and I can tip it up so that it looks like this. So now this is my 90-degree angle, this is 60, and this is 30. And I can do the whole problem again, but with a different tip on it. So now I'm going to erase a few of these marks on the red triangle just so we don't get confused, okay? Any more than we need to, at least. And this 60-90 side we decided is 1/2 because look, the radius is still 1. Do you see that? The distance from the center out to the circle is still 1. So we are still looking at this triangle up here. We've got a hypotenuse of 1, but now the values have flipped. My 60-90 is on the x-axis and my 30-90 is up on the y-coordinate. So this is √3/2. So if I look at this point on the unit circle, that point is called 1/2. That's your x-coordinates over 1/2 and up √3/2. Okay, and we get another coordinate on the unit circle in the xy coordinate plane. All right, now we can also make these triangles, draw these triangles in all the other quadrants. I'm not going to go through and do all the work, but I'm going to just show you, like, here's a triangle, right? This is like our green triangle flipped over into the other quadrant, and here's another triangle right here. Okay, that's like our red triangle flipped over. That's supposed to be on this circle, you can pretend. That's like our red triangle flipped over. Okay, and we can go all the way around the circle drawing these triangles. In addition, I can also draw the 45-45 triangle on here. And here's where the 45 goes. It's right in between the red and the green. It's right about there. Because a 45-degree angle is right between, 30 and 60. So it's going to find its place right about there. Right triangle. Okay, and we can do this similar math. I'm not going to walk through it all again. But this radius is also 1, which makes this side √2/2, and this one √2/2. And you can do the math up on this triangle just like we did on the 30, 60, 90. And that makes this coordinate √2/2, comma, √2/2. Okay, and that's also a unit on the point on the unit circle. Now, what the heck? Why are we doing this? Why do we care? Well, let's, here, let me, here's what it looks like all labeled out. Okay, now we haven't, I haven't drawn all the triangles, but you could come in here and go, oh, okay, here's 30 degrees, right? That's the triangle. You just drop the vertical. Here's 45, drop the triangle. 60, drop it down. So that's just our previous one. But this, what this is all of those coordinates labeled in all the quadrants, doing that same math in each quadrant. But here's the deal. Over here, just forget about the circle, think XY coordinate plane. These points over here in the XY coordinate plane are positive points, right? You go over and up. You go positive in both directions. These coordinates over here are negative and positive in the XY coordinate plane. That's why you see all of these coordinates having a negative x value. In the fourth quadrant, the points over here are negative. So that's why you see double negatives in each of these coordinates. And over here, they are positive, negative, these points. Okay, so that's why the signs are changing, but notice that the numbers are kind of the same because they're all built off the same triangles, just flipped around the origin. Okay, here's why we care. Let me erase some of this so there's not too many markings on here. Let's look at one triangle. Let's look at this one, the 30, 60, 90. We decided that this side was root 3 over 2 and this side was 1/2. So if this is my angle theta, the question is, what is the sine of theta? Well, you learned in section 1:1 that the sine is the opposite side over the hypotenuse. And so on this triangle, my opposite side is 1/2. So it's 1/2, and my hypotenuse is here, it's 1. So it's 1/2 over 1, which is just 1/2. All right, and then let's look at what's the cosine. I've gotten wonky with my colors here. I don't know what I'm doing. I'm going back to black. Okay, cosine theta. Cosine is adjacent over hypotenuse. And the adjacent side of this red triangle is root 3 over 2. And the hypotenuse, again, is 1. So over 1, which is just root 3 over 2. What does this boil down to? Because on the unit circle, the hypotenuse is always 1, that means that the sine ends up just being the y-coordinate. Look at it. Look at this point. That's 1/2, and the sine is 1/2 there. And the cosine ends up being the x-coordinate. Because you're always going to divide by 1, it just ends up being the 2 legs of the triangle. So with this idea, we can redefine the trig functions. Instead of sine being opposite over hypotenuse, we can say that sine of theta now, in terms of the unit circle, is the y-coordinate. And the cosine of theta is the x-coordinate. Now, what about the tangent? Let's look at that. Tangent of theta is opposite over adjacent. Well, the opposite side is 1/2, and the adjacent side is root 3 over 2. But look at what this is. 1/2 is the y-coordinate on that point, and root 3 over 2 is the x-coordinate. So we redefine tangent theta as y over x. Okay, similarly, cosecant is just the sine flipped over, so it's 1 over y, or flip the y-coordinate. Secant is 1 over x, or flip the x-coordinate. And cotangent is x over y, or flip the tangent. Okay, so we have these new definitions of the trig functions. You should memorize these. You should be able to flip back and forth between, in my brain it goes sine, opposite over hypotenuse, y-coordinate. I have both of those in my brain as definitions of sine. If I'm looking at triangles like we did in section 1, I'm thinking opposite over hypotenuse. If I'm on the unit circle, then I'm thinking xy coordinate. Now here's why the unit circle is helpful. I'm going to pull this. Maybe. Nope. Oh my gosh. Why can't I grab this thing? I don't know. Okay, never mind. I'm gonna just erase. Okay, I'm gonna erase these two because I want to use this unit circle. I thought I could pull it down to the next page. Okay, here's why this is helpful. Remember those problems that you did in section 1:1? We said like find 5 times the cosine of 30 plus root 3 the sine of 45, say. Okay? And you had to draw a triangle for each of these and figure out what the ratio of the sides was. Well, with these definitions, all I have to do is look at the unit circle and peel off the correct coordinate. Okay? So here's how this looks. I've got 5. What's the cosine of 30? Well, I find 30 on my unit circle, and because cosine is the x coordinate, I go over here and I say, oh, that's root 3 over 2. And then I want to know what the sine of 45 is, so instead of drawing the triangle and doing the ratios, I go over here, I find 45 degrees, and the sine is the y coordinate. So I look right here, y coordinate, oh, that's root 2 over 2. And then I can do the math just like normal, just like we did last night. So 5 root 3 over 2 plus root 6 over 2, which is 5 root 3 plus root 6 all over 2. And that's your answer. So it's a lot faster than the triangles, and it's still giving you exact values. Now, it's up to you how you want to proceed in this course. I personally think that it is better and easier to memorize this unit circle. Okay? Some people like the triangles, and they end up using the triangles for the whole course. That's fine, and you can do that. But you have to memorize one or the other. So you either have to be able to do the triangles or memorize this. I think the unit circle is faster. Your teacher in calculus will probably reference the unit circle. If you choose to memorize this, let me show you what the pattern is, because it's not as bad as it looks. Let's take green here. Okay, I memorized this first coordinate. This first coordinate is root 3 over 2, 1/2. I remember that. And then the next increment of 30 degrees, which is the 60, the values are flipped. Okay, the next increment of 30 degrees, the numbers are not flipped. So when you jump across an axis, like the y-axis, you don't flip the numbers. But then within the quadrant, you do flip. See how these guys are flipping the order? But now I'm going to jump across an axis system, so I'm not going to flip. They stay in the same order. Within the quadrant, they do flip. When I jump the axis, they don't flip, and here again, they do. So that's the pattern. So I can write all of those down by memorizing just this one point and remembering the pattern. I can write all of those down just with the flip, no flip, flip, no flip, flip, no flip. And then I go through and just assign the signs, which is based on the XY coordinate system, which I understand anyways. These are all positive. These guys are going to be negative positive, so I put a negative in front of all the first terms. These are negative negatives, and these are positive negatives. Okay? And then the 45-degree angles are easy because they're all the same. They're all the same numbers, just with different signs. So all you have to do is memorize the point root 2 over 2, comma, root 2 over 2. So basically, all you have to memorize is 2 points and the pattern, and you're pretty much done. So you choose how you want to roll, but I would highly recommend memorizing the unit circle. I'm going to stop this video, and I'm going to break this section into 2 videos. So I'll stop here, and then I'll do some homework problems for you after that.